Welcome, and in this video we'll be talking about the big O of n factorial, which is the factorial time complexity. An algorithm with the factorial runtime complexity increases factorially with respect to the input size. So in other words, the factorial time complexity refers to the time complexity of an algorithm that grows in a factorial way based on the size of the input data. So many people understand the word number factorial, but let me just do a little example on that. So when we say number factorial, it means that the factor of a number is the product of sequence of integers from 1 up to that number. Okay, so for example, you can look at 1 factorial, right? So we only have 1 there, which is the 1 factorial is what? 1. If you look at what 2 factorial is going to be 2 multiplied by 1, which will give us 2 in total. And for 3 factorial is going to be 3 multiplied by 2 multiplied by 1. And for 4 is going to be 4 multiplied by 3 multiplied by 2 multiplied by 1. So it goes in that fashion. So this is what we call number factorial. So you can now think of an algorithm that has this implementation that multiplies every property of the indexes in that particular sequence. For more clarification and code example, let us look at the code example I have here in my VS Code. So I have created a file called factorial time, and I have this code here, which is the big O of n factorial. Now, what this code does, it takes in an input array and it generates the permutations of this array. This is the name of the function and this is the body of the function. Let me run this code and let us see the return result. You can see we pass in an array of 3 elements and it returns the permutations of the given input array. Now, what makes this code the O of n factorial? I want you to look at this part, right? You will notice this is a loop, which is O of n. If you look further, right, at this part, you will notice in this loop, we are making a recursive call. This is the recursive call. So it's going back to call itself again. And the recursive call has a return statement. If we look further, right, if you look at this line, you will see there is a nested loop. And this nested loop is depending on the result of the recursive call. So this part of the code is what make this algorithm the big O of n factorial. If we look at the big O complexity chart, we will notice that an algorithm with the time complexity of O(n) factorial has a growth rate of nearly vertical. You can see it here. You can see this is the start point and it just goes straight up. So this make it extremely inefficient for large input size. Okay, so this type of algorithm is not good, is not efficient for applications that are in production. It is important that when you are building an application for production or for public consumption or for public usage, it is important you scrutinize or refactor your algorithm to fit this one with fair, good, or excellent, which is the big O of log n, the big O of on, the big O of O of 1, and a big O of n log n. So guys, we have covered the big O notation, and in the next video we are going to do an overview of the big O notation. Please ensure you like and subscribe. I will see you in the next video.